Okay, so I've got a demonstration that I did for you. I did it in front of a green screen thinking I was going to use a background. Realized as I was editing it that it was too hard to see the objects that are falling, so it's just in front of a green screen. It would be better if I had filmed it in front of something other than green. But in any case, here's the situation. Let's say that you've got two objects. And the one of the stories usually goes is an archer who's shooting a bow. And let's say that archer is shooting that bow, that arrow, but shooting a bow. You don't shoot a bow, you shoot an arrow. The archer is shooting the arrow horizontally at a target. So the archer shoots it horizontally, right? It falls when it shoots horizontally, but shoots it horizontally. And at the same moment that the archer shoots it horizontally, let's say the archer, I don't have my watch on, the archer's watch falls off at the same instant. So at the same instant that you shoot something horizontally, something falls down vertically. And the question is which gets to the ground first? You should think about it. And actually it's an interesting question, and actually to the point where the Mythbusters did quite an episode on this, where they took an actual bullet from a gun, shot it at the same time as they dropped something. But in any case, think about it, and I'm going to do this demonstration for you. I'm going to do it with an apparatus that has two ball bearings, two large steel balls, and the apparatus is made so that it shoots one horizontally, exactly horizontally, at the same instant that the other is dropped vertically. And so in the demonstration, you're going to see this where I do it once, and then I'm going to do it again where I change the green screen to a black background to try to help a little bit. But I do it in slow motion each time. It's the same motion, just repeated. And in the second time, I'm going to show you horizontal lines that show the level of each ball every second. It's not really every second because it's slow motion, but every second in the slow motion. And to see where the steel ball bearings are after every second in the slow motion video. And then I show it a third time just in case you didn't catch it the first three times. So let's see if I can show the video. How do I switch? There we go. Okay, so this is the video, and here's my apparatus, and I don't know how to make a pointer, but that's okay. You will see where the balls are in a second. I'm going to go ahead and play, and listen for when the balls hit the ground. Did you hear one bounce, or two bounces, right? That the balls hit the ground at the same time. So if you shoot one horizontally, that's the one going to the left. You drop one vertically, the one on the right, fell straight down. They actually hit the ground at the same time. They bounce, and then one hits the cupboard, so then they sort of get off sync. But anyway, there's one. Just make sure you see. There's the second ball. I'm going to shoot them, and there's the orange lines every second. Boom. They hit at exactly the same time. So what this demonstration shows, one more time. Boom. Whoops, didn't mean to replay it. Is the independence of motion in two directions. This is an important concept in physics, that if you shoot something horizontally or you drop something from rest vertically, they hit the ground at the same time. Why? Because in their vertical direction is independent of the their vertical motion is independent of the horizontal motion. And so in the vertical direction, if you just take the vertical direction, that the ball being shot still has a velocity in the, let's call it the y direction, of 0. The ball being dropped has an initial velocity of 0. So they both have an initial velocity in the downward direction of 0. They both have the same distance to go in the downward direction. They both have the same acceleration in the downward direction, which is 9.8 meters per second squared. So therefore, they both take the same amount of time in the downward direction. What's the difference? That one ends up farther away because it also had a horizontal component of velocity, just like the swimmer in the river. Thank you.